Okay, I think we just start because we just did our last rehearsal now and we figured out we are much over time. So this will be fun. We want to talk about engine tools for performance in open world games.
Yes, I'm Mario Plamero from the Unreal Engine team for the evangelism for the Southern Europe, and he is
Andreas. I cover Western Europe, also evangelists. Yeah, what we want to talk about is those things. So some disclaimers up front. We are both not artists, okay? So what you see is maybe not the most beautiful thing ever. We want to cover basically the tools.
Yeah, we will be covering these tools and how those perform with open world games. There's this question that everybody asks us when we are traveling and visiting studios, and is how I can improve the performance of my game if I'm trying to do something more or less open. And that's a question that everybody asks us. So we are trying to address that with this talk right now.
So one question first. Who of you has shipped an open world game? Okay. That are much more than I hoped for. Okay, so you might know some things better than us. So who of you is working right now on something you would call open worldish? Okay, why is the rest here? No, sorry. No, sorry, just joking. So only to manage expectations here, we're talking about the stuff that's currently in the engine. We don't talk about the stuff that will come. Nick talked about a little bit on the roadmap. So we will not cover that. So especially the ones who have shipped already might have, so you saw who raised hands, ask them afterwards. The really hard questions. So let's dive into it.
Yeah, let's start. I will start talking about those tools that are about creation for open worlds. So for example, landscape. What the landscape tool does is to create grids of quads that can be modeled in engine. They're very good for creating terrains and outside.
Sorry.
Yeah, outside environments. They are composed by layers, so we can create different layers of different terrains, and they are also built by components. We're going to see quickly how this works. Okay, let's go to my map, don't save. So for example, we go to the editor, we say create new, and this is a landscape. How can we create a landscape? We can create them from scratch, like that one. So we say create new, we select the resolution of the landscape, and click create, and there we have it. If we will have light, I'm going to bring a light here. Sorry. Directional light. Just like that. Okay, sorry. So we also can create a landscape from height maps, like this other one that we have here. This is an imported height map that we created beforehand. And we also can add new components to existing landscapes. So we can extend our landscapes once we have created them, just like this. We come here and select add, and we will be creating new pieces for this landscape. Okay. We also, if we're working with world composition, can bring in tile height maps, and each tile is going to be a new level, and each level will contain a new landscape with the selected height map. Or we can create adjacent maps to another level with the same resolution and the same scale. As I said, it's important to know the landscape have components because we can delete them, add them, but this is important for open worlds and that we can split them in different levels. So for example, I imported this as a whole height map, but then I split it in different levels. So for example, I can just hide it to see that all the foliage and everything in this landscape went off. And we also can change resolution of our landscapes once created. So as I said, if we use the Move to Level tool that is right here, Manage, Add, Move to Level, I can bring another level in. So if I select the new level and I say, let's move this to another level, it will automatically bring those components of the landscape to the new level. Okay? So in this way, we can plan our streaming for our open world. And it will carry our foliage with it. So the important thing about the components is that they are going to behave like a single mesh. So the more components we have, the more droggles that we'll have. Landscape also come with auto-loading capabilities. So for example, I'm going to change my mode to view mode, landscape to 5. What I'm doing there, landscape.debug view mode 5, it's changing the view mode so I can see the loading of this landscape. LODs, sorry. So I can see what LOD level is using. But if I turn to wireframe also, I will see that it's tessellating in the first level, so it creates mesh automatically without me doing anything at all. So it gives us more resolution as we approach the landscape, and that means that we are not using extra memory or any extra draw calls for that. And another cool things regarding landscape is that they handle collision very well. So it's really optimized for collision and very optimized for the movement component that we use for characters. So good things about using landscape for our games: auto LOD, tessellation, collision optimize. Something that is equal on other methods is that draw calls increase with the number of components for our landscapes. But the drawback of this technique is that we have a limited control over creation of meshes. So for landscape, we have to balance our component number. So we have to plan ahead when we are starting to do our levels to know the number of components we're going to use, because the more components that we get in, we will have more control over our landscape, but also we will have more draw calls. And we also have to have in mind what kind of usage are we going to do with this landscape. Because if, for example, we are doing like big spaces of open terrain, we can probably afford to have larger components with a less resolution, because we are going to have a lot of draw calls around if we increase the resolution. But if, for example, we are in a city and the builds are occluding our landscapes, that will allow us to have better resolution, because we will be occluding those and the draw calls will be reduced, unless we are like swinging from building to building. So some useful commands for debugging when you're working with landscape: show landscape, that will enable that will hide or show the landscape. That's good to have in mind, because this way you can quickly see if the landscape is being a problem with your performance. Also the debug view mode that I used to see the LOD distribution or the wireframe on top. We can print the number of landscape shadows. So we can print the number of landscapes that are being processed for shadowing. We can we can enable or disable cascade shadows on landscapes to see if that's an issue. We can also change the LOD bias and also the distribution scale of LODs. So to make beautiful our landscape, we want to use Foliage. Foliage will allow us to place big amounts of static meshes in our landscapes or in big static meshes. And it will group all those static meshes together. So they will be handled like a one single entity. Instancing those will reduce the draw calls. It manages static meshes on chunks. Those chunks are, as I said, are a whole entity. So we can manipulate instances one by one. The bad thing about being chunks is that for occlusion, we're going to have problems with that. The whole chunk is going to disappear if we don't set the occlusion properly. So being instances, the engine can handle thousands to millions of static meshes depending on the platform. So again, it decreases drastically number of draw calls, though it doesn't reduce polycounter overdraw, but it's managed by as chunks, so for occlusion purposes, it's a problem. One cool thing that the engine has for Foliage is you can set the scalability. That will reduce the number of instances depending on the power of the machine the game is running on. We can set, if we set density scaling for, we can set density scaling for each type of foliage. So we decide what type of foliage is going to be disappearing and in what amount depending on the power of the machine. But be aware that if we have a static meshes with collision, the collision is not going to be removed. It's going to be removed only the visual representation of the static meshes. There are 3 ways of creating foliage. Brushes is the most common one. Grass tool, procedural foliage volume. All these techniques allow us to put particular foliage types depending on the layer that we are working on. For example, we can only put like obsidian spikes on only when the floor is infested by alien things. So the most common one, as I said, foliage brushes. I'm going to come here, and most of you already know this, but you come here, foliage, you select painting, and placing instances just like painting in a layer of any other software. So we can select the foliage type that we want to play and just play them. Okay. We can select the density here. So if we reduce it, it will be has less density, and so. But the thing is, this is the most common one. This again allows us to, if we select the instances, it will allow us to modify them and place it one by one. But that's not the idea for foliage. We also have grass tool. This is not so common. Grass tool will allow us to spread foliage type to all the extension of our landscape. But again, if we filter, for example, we are filtering here the flowers and the grass on the grass layer. And this was used to make this landscape. So if we go to this asset, environment, landscape, foliage, here's the asset that allows us to, that sets the density for each foliage type. And here in the materials, materials of the landscape, you set it up just like this. You select the layer that you want to use. I'm here just reducing the amount of density, and I'm saying that it will use this grass type. So this will spread grass all over our landscape. And the other tool is the procedural volumes. Disclaimer on that, it's still experimental. It's been experimental for a while. But it uses a very organic algorithm to place static meshes on our landscapes. We can control, for example, I have a blocking procedural foliage volume. I'm placing bushes here using this volume here, this volume here is placing these trees, but I don't want these rings to be altered, and I don't want to place here trees. So I created a blocking volume. So we can have control over this algorithm. This technique will also allow me to modify the instances once it has been simulated. But by the way, this doesn't allow to modify instances. But the problem with this one is that it ignores foliage scalability. So how it works? I plant some seeds. I define the distance between seeds and the amount of seeds, and I define the range of the collision for those instant meshes. So no instance is going to be spawned inside the collision, this red circle. And then from those instances, I spread some seeds, and again, more instances around. The yellow circle is the shade of that instance. That means that I can define foliage that will only grow inside the shade, or foliage that never will grow inside the shade. So for example, if I want pine cones to be underneath pine trees, I can define that those are only going to be placed on the shade of the pine trees. And so on. We can define the number of steps, and as we can see here, it creates very organic look-like foliage. Okay, these bushes have been placed with this technique. So, as I said, foliage is very good to reduce draw calls, but it's not that good for overdraw or polycount. So, because foliage is usually using mask materials, we have to find a good balance between overdraw and polycount. So we can increase the number of polygons to reduce the overdraw of the mask materials. But again, we have to plan ahead how much it will cost us. Like we see here, the bushes on the left are not have no overdraw because all the leaves are modeled, but the grass is causing some overdraw on when we have several amounts of them, one after the other. As we can see here, grass has a lot of transparent pixels. So some useful commands for foliage. Show or hide foliage. Again, if we are having troubles, the first thing that we can try is the foliage causing some trouble. We can change density scale as in scalability settings. We can log what foliage is being rendered at one frame. We can freeze or unfreeze to see the occlusion. We can change to dither LODs, so they have a better smoothing transition. We can force an LOD level, we can set a minimum LOD level, or we can set the distance scale. So now, for creating levels, I'm going to talk about wall composition. Wall composition is a system that it's been there for a while and allows us to handle levels by distance. So when we are close to a level, it will load up, and when we get far away, it will be streamed out. When we activate wall composition in our system, that will load all the levels that we have in our content folder. So for example, here we can see all the levels in our level tab when we are using wall composition. Wall composition looks like this. Okay, so we can select levels and see where that level is. Stream map only if we are really close to them, so we can create that kind of level or one for levels more based on landscape that can be seen from the distance. Okay, and as I said, if I unload this doesn't mean that the levels are not there. If I hit play, the levels are going to be streamed automatically by wall composition. Okay, so again, I'm going to load everything so it's easier for us to do the talk. So the problem with wall composition is that is a very horizontal tool. It means that it will take only in consideration distance in the X and Y axis. And it will take on account the boundaries of the level that we're looking at. For more verticality options, we still can use the traditional load level, so it's not one or the other. We can have both. And for example, if we want a level not to be streamed at all by wall composition, we can come here and create a layer that is like not streamed, and check this out. So if I place this level, I move this to this layer, not a stream, it's never going to be a stream in play. And that means that I will have to load it in the traditional way of using a blueprint or a C++ function that loads that level. So wall composition is seamless as long as we have cooked content. So in the editor, it's not going to be asynchronous loading. And as long as we activate use background level streaming, that is now enabled by default in the editor, in the project. My favorite part of wall composition is that it can create level LODs. So that means that for our whole level, it will create a new level that is a simplified version of the level, and will gather all the static meshes together, and will create one only static meshes for all of that, and one static meshes for all the landscapes in that level. So we will have two draw calls for the LOD level. We can have a look at one of those. For example, here, maps. It just and it finds them automatically because of this LOD suffix. So this was generated by wall composition. It's just this mesh. And if we had, for example, a static meshes on it, we'll also have another static mesh and put them on this new level. And to do that, we have just to go to level details and put these settings, like what distance I want this LOD to be loaded. This is relative to the already level streaming distance that wall composition is using, depending on the layer. And I can set the number of LODs, for example, and some settings, and just click generate. And depending on the amount of static meshes and landscape, well, can take some time, but it's pretty cool. So the only thing I can say about this is that it doesn't have dither transition like we have in Foliage. That will be pretty cool. So this works more or less this way. If we have a level that we are going to approach with some meshes, and though that level has a streaming distance of 50,000, and we have created a level LOD at a distance of 50,000, until we don't get closer to than 100,000, no level is going to be loaded at all. But once we get closer, still farther than 50,000, we will have the LOD level with these two meshes, the LOD mesh that we create for all the static meshes, and the level and the landscape LOD. And when we get closer, because for example in this example I'm setting also an LOD for the meshes I'm looking for, we will have the level already loaded with all the landscape, and I don't know if you can see the foliage over there, for example. But we will have to have a solution between those distances for LOD for our meshes. And then when you get closer to the distance, we will have everything final. So wall composition is very good for managing levels automatically. It also reduces, if we use level LODs, it will reduce a lot draw calls, poly count, and material complexity. It's asynchronous as long as we activate it. but has no verticality at all, and we will have to handle that by hand, and it has no dither transition. And now I will hand over the talk. No, sorry. A couple of commands, stat levels. This is the key for levels. This shows when a level is has been streaming and the time that it took to stream in. When a level is loaded but not visible, that's the yellow one. When a level is not loaded at all, that's the red one, and the pink purple one is when a level is being loaded. And we also can force the garbage collector to recover the memory that a streaming out level left. And we also can, again, ask the engine to do the level streaming on the background. And now, yes, I'm going to hand over the stage to Andreas. Oh, sorry. Thank you. No, I will.
Oh, that's a bad idea to clap in between, because then we have to compare afterwards who clapped better. Okay, my part is more about traditional things you might already know, but the door is closed, you cannot leave. So I talk about the death of 1,000 cuts. What does it mean? I mean, most of the time we're talking about seeing a lot of stuff on screen. So you have to figure out how to minimize on the mask. So it's not like, oh, we have this one object that's a problem. It's more like, oh, we have a lot of objects, that's our problem. So we want to lower the footprint. So how we do that? First of all, we figure out that maybe some things we don't even have to draw because so we want to control the visibility. We want to reduce the polygon. We heard that already a little bit for the landscape, but we'll see that for objects and how to optimize that. Actor merge is something I want to talk about, and a short thing about instance static meshes. So occlusion, I think everybody knows about that. In order of effectiveness, we have distance, so it's easy. It's the easiest check. Then we have frustum. This is actually from UE3, and it's from the real-time rendering masterclass Sjört did. I stole that. I didn't tell him. Don't tell him. And we have a possibility to do pre-calculated visibility, but I don't cover that here because it's not really applicable for open world. It's more for mid-size and smaller levels. So what it basically does, it makes cells, and for each cell it checks before and bakes it in, and then the camera is asking the cell it's in and saying, what do I see? So, and all this is actually done because dynamic culling is the most expensive one. What I can show, you can actually see this pretty nice. Oh my God, this is fast. I like that. So for example, when you go here, you can say freeze, and that's again an English keyboard for a German guy. After this conference, I think I get a new keyboard. So so now you can see what's actually was rendered, which is pretty cool tool to figure out what's going on. So you see here, I have some stuff, for example. So let's bring that back. So that's basically what is done after all this. So distance occlusion, I want shortly to talk about that. So you can set it up per object, and that's actually a good idea to do because otherwise you have maybe cockroaches somewhere at the beach crawling around, and they are still there. So it is checked. So they check if they are there, and that can be costly if it's a lot. There's cull distance volumes. So this is I have an example here. So for the volumes, you can set up some things like on which size, in which distance it should get culled. So if I enable this, I don't see anything. So that's something that happened to me actually quite often. You have to do it either in game or press G to go to the game mode. I was searching for a bug for half an hour before I realized I have to go to game mode. So I did this with big objects here, so that makes no sense actually. That's not what you want, but you get the basic idea about that. So, and one other thing is use large occludes. What does it mean? Actually make your map in a way that you maybe cannot look everywhere from everywhere. So you can actually design your world in a way that you have the possibility to occlude stuff. So occlusion basically isn't checking for polygons, it's checking for the object, and it's using the bounding box for that. And you can manipulate the bounding box scale, but we do not recommend that. It's also used for all the lightning stuff. What we did here is this is fully dynamic lightning, so we don't bake. Fortnite is doing the same. So maybe that's not your main thing, but if you tinker around with this, it's hard to find afterwards. So if some artists figure out, oh cool, it's occluded too much or too less, so I change the value, half a year later nobody will find why this object is suddenly appearing or disappearing. So that's actually not the best idea, but I tell you anyway. So there are also some commands that help you with that. So one is the visualize thing. So let's see. So visualize primitives. So if I set that to 1, you actually see all the stuff that is occluded right now. And it's really funny, when I tested that, I figured out, oh, I copied some stuff below the landscape, which is actually a waste of, so this one. I should delete that. Okay, let's bring the landscape back if I find it. So, and let's go. That's something in rehearsal we always do wrong. We stick to state, and then some slides later, we don't know where we are. So there's some more stuff that is occluding. So for example, that you maybe want to check the particles as well. So I want to talk about mesh reduction. So I think everybody knows about that, but still there's some cool things I really like. We used a lot of other art from other projects in this project, and some of the stuff was just too big. So it's pretty easy to just go there and, for example, let's take this tower here and open it up and maybe show it with where is it with wireframe. So it currently has 2060 vertices, and maybe this is just too big for my project. So let's make it 50%, and then it's reducing already. So I can use this. So this is the good way to bring the content without going through the whole process of, and it still looks nice. So it's, if I don't, the reason why it's so, I switch on the environment, so that's the reason why it looks like that. So okay, that's one way you can just reduce it pretty easily. So how do you find out which of the stuff is a problem for you? What you can do is get rid of the pixel shader costs by lowering the screen percentage. Then you can capture, and then you can profile GPU, and then you get a really nice list, which you can see here, about all the stuff that was in the base pass. And then you can see, for example, our biggest one is actually a flower right now in this project. And then you can figure out where you want to focus on. So one thing that's really, if you have a lot of stuff, especially when it's really different things, or it's procedure generated or whatever, you maybe don't want to do this all by hand. What you can do is, there are groups, there are LOD groups. So for example, this one is a level architect, but here are different ones. You can define them by yourself. I show that later. And then with that, you can generate, for example, more LODs. So let's do for this tower, let's do 4. So it's generating 4 of them. But what I wanted to show actually is more this one. So what you can do is you can define all LOD groups. You can do that either in the base engine, but maybe it's better to do it in the project's ini file. And what you also can do, which is pretty nice for scalability, you can set the minimum LOD per platform. So I can say, for example, for, I don't know, for Switch, we go for the minimum of 2. So that helps for scalability on different things. So in the next step I can use the blueprint utilities to actually generate the LOD for a lot of assets at once. So what I did here is with the blueprints, here's a blueprint for that. So what's basically checking is what I've selected in the editor. It's checking it out. I'm not connected, so that's the reason why it's like that. And then I either remove the LODs or I generate them. So let's bring that up. So what I can do now is let's go in this folder where the stuff is, select all, and now I can say generate LODs. So what he's currently doing, he's checking out everything. We are not connected, so I hope it works. And then he's generating the LODs for them. So it takes some time, but it shouldn't be too long. When I tested, it was nice. And then we can then directly see it in the viewport. So it's a lot of assets. I choose the wrong folder, but whatever. Let's wait for that. Here are some additional commands while he's running. So you can force the LOD, I will show that, and you can set the distance scale. But the commands are those are for the whole scene, not for single objects. So let's see, is he done? Looks good. So I hope now it worked. Yeah, it doesn't. I don't know what we have changed here in this level, but here you can see it on the bushes. It should work like that. So it should look like this. And I don't know what we messed up when we trained this here on stage. But whatever, I think that's fine. So what does it do? First of all, it decreases the GPU load. It doesn't reduce the draw calls, obviously, but it can increase also the load times of memory usage. So for us, it's always like that when we go to others and try to help with their projects. There's never, ever the golden answer for everything. So you have to see what trade-offs you want to do. So merge actors. I want to talk about merge actors very fastly. So it's actually combining multiple actors in a single mesh. So that's something we prepared here. So and maybe we go in this mode. So for here we have a thing that's belong 1, 2, 3. I think it's 9 different meshes. So you can select them, and then I can go to Edit, Window, Developer Tools, and then there's Merge Actors. And here I can set up some stuff. I can say which LOD levels are used. I can say merge with materials, and then I get that. So what you can notice is if you do this, I reduced only from 7 draw calls to 5 draw calls. The reason why it even reduced is because there are some of the meshes that share material. So this is actually pretty good if you have something that you have shared material and you have a lot of different instances, then this is a good thing. But actually you want to go further, and that means you can also merge with the option of merging the materials. So that's something I did here. So this one actually is one model, and you can see he has only one material, and it looks nice. So what you basically get there is now I have one draw call, and that can be a big difference when we talk about a lot of different objects. So even if when you reduce from 9 to 1, that means maybe not much for the single object, but if you have a lot of them, that means a big difference. So the next one I want to cover is a proxy geometry tool. This one replaced recently third-party tools. What it basically does is taking the meshes, voxelizing them, and making a new mesh and a new material out of that. And you can set up some parameters. So that's something we did here. So this one, for example, it consists of 3 different ones. So when I select those, and I go to the merge tool, then there is a second tab here, and there you have a lot of settings. I don't go into detail too much here, but basically you can set the screen size. That's what I did, and then build it. And then I have here one which is one screen size of 300. So it still looks pretty good. This one, okay, our angel here is okay. This is really beautiful. But you have to imagine this is made for kind of this kind of distance. And then it doesn't make a big difference visually, but it makes a big difference in polygon count. So what you can see here at the end, the ugly one is 551, has one material. So and the other one is 4,850. It can make a difference. What you also can do if you have a building or something that's hollow inside and you cannot see, you don't have to watch inside. It's a really nice thing. You can use a parameter called merge distance, which is here. So you can pump that up. You can also put a color for the geometry that he's generating, because in this case he's generating a new vertices. So what he's doing is, and I really like this picture, he's blowing it up like a balloon and then shrinking it down again and then merging the as a result with a voxelized new static mesh. And then you see here the entrance got blocked. So what does it do? The render call gets obviously reduced, but there is some possibility, and that's something you have to be aware of if you do it, if you overdo it, if you do it with big things. And as said, it's checked with occlusion for the whole object and not for single vertices. Then maybe the whole thing is loaded and wanted to be displayed. So in the combination of all that is the hierarchical LOD, which combines multiple static meshes. It's not destructive. It lives in the level, and it's done in 2 steps. It takes some time. So I do this really quick now because we're running out of time. I'm loading the map with a P. We have a second POE here. No, that's not the one. Cancel. This one. I don't save. So let's go to unlit mode because he has no light, and then you see our temple again. So it's a thing that's based, it is per level setting. So first of all, you have to enable it here with enable hierarchical LOD system. Then you go here and you have hierarchical LED outline. And what you want to do is first you want to build some clusters. I think on this machine it should be pretty fast. I choose a small one. You can even say you have different HLODs. So let's put just for fun a second one. I generate the clusters. So now you can see what he wants to cluster together. So it's depending on the distance you have between those objects. So that is what he wants to do. You can manipulate that. I can move stuff around, but I go with that. And then I say generate a proxy image. It takes some time, and it's advised. I mean, if you move stuff around in the level still, you should test that, but each time you move something around, you have to rebuild. So it's really, you have to see it a little bit like baking lights. So maybe you don't want to do it each day. Maybe you don't want to do it on your PC. You want to do it maybe in a build process during the night, and maybe you want to distribute it to different machines. But basically what it is now doing is making all these different chunks. Yeah, there are. I'm waiting until he's done. There are some things you have to take care of. So mask and opacity isn't working there. So maybe you want to uncheck merging textures in that case, and then the original material is used for that. That's important to know. What's also important to know, it's as I said, is referenced by the level. So maybe you want to check your memory. It needs rebuilding. I said that, and maybe you don't. You have to think about how to include that in your workflow. So basically, it's the same for LOD, but in advanced here is a little bit more, and you have to be aware of that. Increased loading times and memory usage because you have more models now, which you have to take care of. So I think this one is it ready? No, it's not. Okay, so do I wait? It's interesting. We tested this on this machine before we. There it is. But it's best to see actually in the map. And I hope it's showing now. Mario, whatever, right? We never need this again. Okay. And so I load the levels. And now if I can show it here, and that's the reason, by the way, why the LOD didn't show up, because here the LOD is already it was covered by the HLOD. That's the reason. So here you see the HLOD now in place. So here is the highest one I made. And when I get closer, he's loading in. He's replacing the chunks by the highly. And now the LOD would take over if I would have one. I think the temple is somewhere. Actually, we didn't fly with a drone. I worked so much on this nice drone. We should fly with a drone. So it's even taking the height, you see? Ooh. Sorry. Where it is? There it is. I teleported it. It's a nice idea. Here we are. Okay, so here's our temple. And now it's loaded in. So the first stage is what Mario said. You have maybe the full level with a static mesh with everything really, really far away. Then HLOD goes over, and then you have the LOD we did. So automatic mesh instancing, I don't say much about that because I think Nick is giving a talk about the refactor of the renderer. He can do that much better. While working on this project, we figured out there's a really good command. You can disable and enable it right now in real time. So we tried that, and for us, this is of the scene of the ruin. You see there, the difference is this. So it's quite significant. And only a side note: there's a Foliage system that's also using automatic instancing, but you can do stuff by your own. So for my last game, we made planets with stuff on that, and we had to also generate cities, and there were no gameplay implication with those. So we did an automatic system and instance that, and that can help greatly. So how about time? Oh, it's okay. So the last bonus I want to say is a little bit looking into garbage collection, because it can be an issue when streaming in and out stuff. So basically what you experience is hitches through garbage collection. And the reason why that is you have temporarily a lot of stuff in the memory, and many of those objects have to be deleted at once. So the really rough, so if a programmer is here, I don't go, this is really a rough idea about how that works. So it's there's an array with all the U objects and the costs. You can basically say it's about checking and then deleting them. And when you take a look at deleting, it's also about dependency check and then actually deleting the thing. The actual deleting actual objects, we can take that a little bit out of the equation because since 420 there is incremental build, begin destroy enabled, so it's distributing the destroy over time and not doing it at once. So basically we have the checking cost and the detecting dependency cost. So what when we talk with people, some really didn't know how to approach that. So one thing first is profiling. So there is this is a mouthful, lock, garbage, lock. So what it basically does is you lock the lock garbage and put it into a lock. And then you can look that up, and there's stat dump hitches, which you can use. There's a start file, stop file, and the CPU profiler. This is all documented. You can go in depth there. And in the documentation. And there's also something many people didn't know. There's a blueprint stats plugin you can use to figure out which maybe of your blueprints causing the problems and what kind of problems you have there. So how do you optimize? You can split further levels, but as also Mario showed you, it's you have to consider that pretty early it has a high impact. I mean, that's completely an obvious one. You can figure out which of the stuff you have in your game is permanently there and needed. So you can make them permanent resident objects. So you can actually, in the array, you can block stuff that is not even checked. You can figure that out. There's also part of documentation you can check. You can cluster. You can decrease the number of U objects. So for example, one we saw quite often is you have macro and macro and macro. That means you have a lot of local variables flying around which generating the U objects. So it's maybe good to look into that and seeing if you make a function out of that or even native the UIs. So there is, when you look in the project settings, you find some stuff there. So what you basically can do, I give only the idea about the basic concept. Please check the detail in the documentation. What you can basically do is when you load up your games, you can set the amount of time, the amount of the object pool, you can reduce it so much that the game is telling you in the log file how much it would need at after init view, and that is the one you can log. But as said, I encourage you to read more about that if this is your thing. So have you oh, no, I'm alone, okay. Cool. So that's what we wanted to cover. As said, it was meant to be a little bit an overview, and then we really hope that you find some stuff that was interesting for you. You want to dive deeper in. Also, as said, it is about the stuff that's currently there, not about the stuff that's coming up. I'm personally really looking forward about the stuff we do in open world this year. Okay, so thanks a lot. We hang around. If you have other hard questions, we try. If we can't answer them by ourselves, then we try at least to push you in the right direction.
Yeah,
Thanks a lot.
please feel free to ask.